Hello, algebra students. Mr. Lawrence here, and here is a video about a practice quiz. All right, I gave you a quiz in class, and here's the video. I'm going to go over it. Now, if you haven't done the problems, do not watch the video yet. You can't play this game where you go, I don't know how to do it, I'll just watch the video. You have to attempt the problems first, then watch the video for correction. All right, now honor students, you're watching this, you're not going to have me in class anymore before the real quiz, so make sure you're doing your best on it. All right, let's get down to it. Let's bring up the first problem here. Oops, that's not it. Sorry about that. Hold on a second, I lost my quiz. All right, I'm going to have to go and find it. I know it's about the problem with, there it is. Oh, silly me, it's right in front of me. Didn't even realize it. Okay, the first problem is, suppose you are in a treehouse that is 20 feet off the ground. Okay, looking out, you see a funnel cloud and decide that you better take cover. First, you climb straight down the ladder of the treehouse, taking you 10 seconds, and then you run 100 feet across the ground to the entrance of a storm cellar. This takes you 5 seconds. Opening the storm cellar, you take 3 seconds to hustle down 15 feet to the safety of the cellar. So I'm going to have to kind of go between things here. Let's see if I can make this a little bit smaller here and bring my video back up. And all right, well, the first thing I'm going to do is going to make a table. Okay, I'm going to do time, right, and then elevation. Okay. And let's see here. Okay. So the time is, of course, at time 0, there's no change in my elevation, and I'm 20 feet off the ground, right? Okay. Now it takes me straight down the ladder, treehouse, 10 seconds. So time 10 seconds, 0 to 10, I go straight down. So, okay, I go down 20 feet. And so now I'm on the ground, right? I'm at ground level. Okay, and then we walk across the ground for 100 feet, and we go. It takes us 5 seconds to do that. So from time 10 to 15, there's no change, and I'm still at 0 feet. Because we're doing elevation, we're not doing distance across the floor or across the ground. Okay, now I open the storm cellars, and then we go down. So from 15, and it takes 3 seconds to go down, then we go down 15 feet. So we go down 15 feet. So now technically we're at minus 15 feet, right? So now that I have my little table done, I can go ahead and get a graph out of this. So let me see here. Okay, scroll up, and I should really lock this in place. There we go. Now I'm going to put my axes in, but notice I'm not going to put them in the corner because I know I'm going to go 15 feet down, starting 20 feet high. Let's see here. If I count by threes. Let's see. 12, 9, 6, 3, 0. 3, 6, 9. Yeah, this is going to work. So 12, 9, 6, 3, 0. So we're going to call this ground level. Okay. All right. And the x-axis is going to be the time in seconds, right? Okay, so that's the time, of course, in seconds. And I really should lower this a little bit, give myself some room. And how long does the story take? Well, looks like it goes through 18 seconds. So I think I might actually count by ones, and 2, 4, 6, 8, 10, 12, 14, 16, 18, and then finally 20 seconds. Okay, now along the y-axis, that's going to be my elevation, right? I can't seem to get that to move. Hold on a second. There we go. So this will be the elevation, and that'll be in feet. I'll do that in green. Elevation and feet. Okay. And I'm going to turn that vertical, and I'm going to put it over here. Okay, now I know I start at 0, and I'm going 20 feet high and 15 feet down. So I wonder if I count by 2, 4, 6, 8, 10. That's only going to give me a 10. I guess I was counting by 3s before. Maybe I'll move this up a little bit here. And let's see, 16, 14, 12, 10, 9, 8, 6, 4, 2, 0. If I do that, I wonder if I can fit. Yeah, I think I'm going to be able to do it. So I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20 feet. And down here we'll have -2, -4, -6, -8, -10, -12, and -14, and -16. Okay, so we know that according to our table here, times 0, we're at 20 feet. And then at 10 seconds, we're at ground level. So what am I counting about? So that's 2, 4, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right there. And so the first part of the graph looks like this. All right, and I guess I should change that color of that, otherwise my black segments are gonna blend in with my axes, and I don't want that. And there we go. Okay, now the from 10 to 15 seconds, he walks along the ground, there's no change. So from 10 to 15 seconds, he's going like this, right? And I've got that a little bit below so that you can tell that he did it. And then finally, for 3 seconds, he goes down 15 feet. Okay, and so we'll get this segment here. And he goes down 15 feet. And so it's going to be right there. Okay. Now, if I asked you to, you should be able to calculate the average rate of change. Remember that R equals the change in the distance divided by the change in the time. So you should be able to calculate this. The change in the distance was 20 feet, and the change in the time was 10 seconds. And so, of course, he ends up going 20 feet, 10 seconds, 2 feet per second, right? And you should be able to do something similar here. Okay, R is going to be, he goes down 15 feet, okay, and he takes 3 seconds to do so, I believe, 3 seconds. And so here, he's going at a rate of 5 feet per second. And there you go. All right, let's look at another problem now. The other problems on here. Let me get them up. I don't know where it is. It's bothering me that it's not showing up at the bottom there, but that's okay. All right, let's get it here. All right. Okay, so it says which of the following three tables of data could represent the areas of different squares, where x represents the length of the side of a square in inches and y represents the area of the square in square inches. Well, first of all, we have to see where the x's are being squared and turned into y's. Okay, now if I square 1, do I get 2? Of course not. 1 squared is not 2. 2 squared is 4, but 3 squared isn't 6, 4 squared isn't 8. This can't be it. It's not A. Let's go down to B. 1 squared is not 2. 2 squared is 4, but 3 squared is not 8. 4 squared is 16, but 5 squared is not 32. It doesn't match. It's got to match on all of them, so it can't be B. Let's check C out. Let's start with 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. Here, 1/2 times 1/2 is 1/4. Absolutely. So it must be C. So C is the graph. So I need to make a graph here. Uh-oh. I thought I had a table, but I guess I don't. I'm going to have to fix that. Sorry about that. Anyway, so you're going to need to make a graph of that. Make sure you label your x and y axes. X will be the length of the side of the square in inches, and y will be the area of the square in square inches. And you're going to plot these points. So let me get a graph up here. Okay. Get a new one out here. Get a sheet of graph paper. Okay. Now we're not going to have numbers smaller than 0. So I can do this and this. And here we're going to have a side of the square. That'll be in inches. And I'm going to move that down, give myself some room. And then along the vertical side, and I'm only changing colors to help you. This will be the area of the square in inches squared. Okay. All right, so I'm going to go like this. Put it over here. Okay, now. So, I've got 0 here. And I've got it's 1, 2. Maybe I better spread this out a little bit. Let's go 1, 2, 3, 4. Let's go 1, 1, 2, 3, 4, 2. 1, 2, 3, 4, 3. 1, 2, 3, 4. 1, 2, 3, 4. And that'll be 5. Okay. Now the area. When it's 1, it comes out to be 1. 2 comes out to be 4, etc. So I'm going to be careful on how I do this. I know 1 is at 1. I'm going to count by ones. 1, 2, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I am counting by ones, but I'm only showing every 4th mark. So when it's 1 inch on the side, then the area is 1. When it's 2 inches on the side, the area is 4, isn't it? 3 is at 9. Okay, and 4 is at 16. And 5 is not going to fit on my graph, okay? I'm going to let that go for right now. And then at 1/2, I'm at 1/4 of the way, so it's like there. Now, this is going to be one of those parabolas we've been talking about. This is an example of a quadratic graph. I'm doing my best to draw a curve. It is difficult with the airliner. It is way easier on paper. Okay, but it's going to look something like that. Okay, you're after something that looks like that, a nice smooth curve. It's part of a parabola. All right, so let's go on and go back to the others and see what they say. Now, I have to determine what type of function A and B are. C is quadratic, right? I just graphed a parabola. It's quadratic. Remember the differences. It's going up plus 3, plus 5, plus 7, plus 9. So the second differences are all 2, 2, 2, and 2. Okay, well, let's check out this first one. It's plus 2, plus 2, plus 2, plus 2. This is going to be a linear pattern. Every time x moves up 1, y goes up 2. Moves up 1, goes 2. Here, let's do that on a graph for a second here. Let me get a new graph. Okay. And I don't care where you start on this graph, but let's put a point right here. And as we go 1 in the x, we go 2 in the y. 1 in the x, 2 in the y. 1 in the x, 2 in the y. 1 in the x, 2 in the y. You see how they're all lining up? They make a perfect line. Okay? So that's called a linear pattern. Okay? Now when you look at B, you notice they're doubling, aren't they? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. They're going up by 2 every time. That is going to be the exponential growth we were talking about. I'll graph those in red. And again, it doesn't matter where I show them. But if I say, 1 is at 2. 2 is at 4. 1, 2, 3, 4. 3 is at 8. 1, 2, 3, 4. It'd be 8. 4 is at 16. 9, 10, 11, 12, 13, 14, 15, 16. This puppy is taken off quick. By the way, at 0 it would be at 1. And so it's going to shoot way up like this. Oops. Now, it's not half a parabola because we won't get it to shoot back up over on this side. If we go into the negatives, they're going to approach the x-axis, but they're never actually going to hit it. Okay, so we'll talk a little bit about that in class. Good luck on your quiz. Hopefully you'll understand what the expectations are. That's it for the video. Mr. Lawrence signing off. Have a good night, everyone.